Hi everyone, today we're talking about angle measures in triangles. Remember, you do not need to write down everything that we'll cover in this video, but be sure to jot down important information and at least one example of each type of problem that we'll cover. Also remember that you can pause the video to jot down important notes, rewind to view information again, and fast forward if you think you got it, but don't fast forward so much that you miss out on something important. All right. So the purpose of this lesson is to talk about the sum of all the angles in a triangle. So what does all those angles, the three angles in a triangle, add up to? What's that number, that magic number? Well, we can use the transversal and the parallel lines to find out. We can use those relationships. If I were to basically color code this triangle, ABC. Angle A is yellow, angle B is blue, and angle C as red. I can actually kind of form a transversal cutting through parallel lines. I actually have two transversals. So I can imagine this as a parallel line, and then the one that A is on, so line X, and then BC kind of form another line. And then these are like transversals that cut through it. So if we think about it that way, it's kind of like angle B and this angle up here form alternate interior angles. They're alternate because they're on opposite sides, and they're interior because they're inside these two parallel lines, BC and angle X, or sorry, line X. And then we'll know that they're equal to each other, right? So it's kind of like I'm taking angle B and I'm moving it over here to this other blue as an alternate interior angle. It's like I rotated it and I rotated it and I translated it up. So in that way, we're moving angle B, the blue, up here to join angle A, the yellow. And then the red ones are like alternate interior angles as well for this line because they're on opposite sides. One's on the left, one's on the right, and they're inside these two parallel lines. So in the same way, I can rotate angle C and then translate it up and move that angle C, the red, up here. And then now you'll notice angle A, B, and C are on one straight line. So that should tell you what number they add up to. And that is 180 degrees. Because after we rotate and we translate and we move them up, they create a straight line, which is equal to the measurement of 180 degrees. So that tells us that the angles of a triangle will always add up to 180 degrees. Make sure you have that in your notebook. This is a very important thing to remember because it's going to help you solve a whole bunch of other problems by just knowing that piece of information. The angles of a triangle always add up to 180 degrees. That's any triangle. Even if your triangle looks weird, it's still going to work out. Or if it's a right triangle, or a isosceles triangle, or an equilateral triangle, all angles will add up to 180 degrees. Okay, so we're going to use that piece of information, and we're going to solve some problems. For this problem, they just want you to know, to figure out what the value of x is in the triangle shown below. So I have one angle that's 98 degrees, another that's 45 degrees. So what is the measurement of angle x? How many degrees is that? Go ahead and pause the video and try it on your own first. Okay, you could have set yourself up with an equation. You know that all three angles add up to equal 180 degrees. So you can just plop them in, 98 degrees plus 45 degrees plus our remainder of x degrees should equal 180 degrees. If this were a normal equation, you would solve it the same way. Add up your like terms, 98 degrees plus 45 degrees. They can be added up together because they are like terms. They're both just normal constants, numbers. You get 143 degrees plus x degrees equals 180 degrees. Then to solve for x by itself, you're going to subtract 143 from both sides. That'll cancel over here. On the right-hand side, that'll leave you with 37 degrees. So that's your answer. That's the algebraic way. If you know that all three are going to add up to 180, what you could do in your calculator is just subtract all the angles that you've been given, the two angles, from 180. So in your calculator, you would do 180 minus 98 minus 45, and you would also get 37 degrees. Either way, it's doing the same thing. It's making sure that at the end, all three of these add up to 180 degrees. There you go. Same thing for this one. You have 180 degrees that it has to add up to. Go ahead and pause the video, try it on your own first. So again, easiest way is just to take your calculator and subtract those two angles because you're going to get what's left over, which is 55 degrees. In your calculator, you can double check and see if these three angles will add up to get 180 degrees, and they should. So that's as easy as the problems will get. It'll obviously be a little more difficult when we add in the transversal and the parallel lines. So we're still using what we learned, that a triangle's angles add up to 180 degrees. This looks really complicated, so I'm going to go through this one with you. They want to know the measurement of angle X. Immediately what I'm going to do is I'm going to read the directions and see if I can create a triangle. Line DE is parallel, that's what this means, is parallel to line FG. So we know these two are parallel lines. And KL is perpendicular, that's what that means. This means that it's going to make a 90-degree angle. KL is perpendicular to FG, KL and FG. So these make perpendicular 90-degree angles. That's an important piece of information. I wouldn't have gotten that if I didn't read this first line. If I just thought, yeah, this is not important, whatever, what's the measurement of angle X? Let me just continue. So that was important. That gave me a measurement. Now, knowing that these are parallel lines and we have a transversal cutting through, I have pretty much set up for me a triangle. And not only that, a right triangle, because they just told me that that angle is 90 degrees. So knowing this, all I need is just one more angle for this triangle, and then I'll be able to find all three. So I am looking at what information I have. I have the 90 degrees. I also have this guy over here. It's a 63 degrees angle. And I can go down my list of what I know. I know about vertical angles, corresponding angles, alternate interior, alternate exterior angles. These pairs of angles are always going to be congruent or equal to each other. So as long as I can find one of these, then I'm good. Well, I know that 63 degrees is right across from this angle right here. So they make what we call vertical angles. So that tells me immediately that this is also 63 degrees. And there we go. I already have two angles in my triangle. So I can just take 180 minus 90. I get 90. And then minus 63, and I'll figure out this angle over here. So that would be 27 degrees. So that means this one over here is 27 degrees, this angle right here. And when you look at that, it's across from angle x, which is what we have to find. It's vertical angles again. So then that leaves angle x as 27 degrees as well. So we just use a whole bunch of vertical angles. We use this information from the directions to find out that was 90. Then we use these pair of vertical angles to find out this was 63. We subtracted to figure out this angle of 27. And then we found out these two were vertical as well. So it was a bunch of vertical angles that were made from our transversal and parallel lines. So that gives us the answer of 27 degrees. And we got it. You could have probably also used other relationships. It's a possibility you can have a different method, but that's one way of solving that. Let's move on to another one last one. This one says, what is the measure of angle x? So we need to figure out this angle right here. All right, let's use the information that we know, that we can see. Well, I don't know this angle, but that's okay. I just need two other angles. I have another angle, but this one I also don't know. This one has some stuff going on here, so I might be able to figure it out. And then once I figure out this angle, I can just subtract it from 180, whatever that is, and then I'll get my answer. So this angle right here is the key. So this angle is unknown, but right next to it on the same line is 116 degrees. Notice I see that they're both on a line. If they're both on a line, it means they add up to 180 degrees. So all I need to do is take 180 minus 116, and I should get that missing angle. 180 minus 116 is 64 degrees. So that means that this angle is 64 degrees, because 64 plus 116 will equal to a straight line of 180 degrees. Now I have only one missing angle in this triangle right here. So I just need to subtract the angles that I do know. I do know that I have a 60 degree and a 64 degrees now. So if I subtract both of those from 180, 60 and 64, I should get my answer. And it's 56 degrees. That will give us this one right here. 56 degrees. And there we go, okay? So you're using all the information that you've learned so far about triangles and what they add up to, the corresponding vertical, alternate interior, alternate exterior, supplementary and complementary angles, and all that to solve for the missing angle. It's kind of like a little puzzle. Let me know how you do as you work on these problems, and I'll see you in class.